In this video, I'll be talking about the VBA script to perform the successive over-relaxation method to solve partial differential equations, in particular Laplace equation. So we're looking at example 8.6, where we discretize the Laplace equation using finite difference, in particular central difference scheme. We ended up getting an equation like 8.26, where the phi ij is related to the north, west, south, and east sides, which are given in terms of I and j. So I is the index, well, in the textbook, I is the index for or along the x-axis, and j is the index along the y-axis, but in the script, I think it's preferred to swap these. But anyway, so we're going to go over this for now. So this is the script for example 8.6 in the textbook, right? So first we're going to declare the number of x points along the x-axis, or number of grids along the x-axis. Number of the grid points along the y-axis is going to be m. We're going to introduce an array phi, whose dimension is not clear yet because we have to know what n and m is. And these are taken from the spreadsheet after we run the code. Delta x, delta y, they're double. I, j, k are the counters for some loops. We have the successive over-relaxation factor, and a variable called phi old, just to record the value of the phis in the previous iteration. So first we're going to read m and n, or n and m, from the spreadsheet, cell 2 and 4. So if you look at the spreadsheet, cell 2 and 4, so here's cell 2, here's cell 4, we're going to read n and m, and the SRF factor from cell number 6, which is given here. After we get n and m, we can calculate delta x and delta y, which is 1 over the number of intervals. Okay, and the number of intervals is 1 less than the number of points. If you have 10 points, there should be 9 intervals. If you have 11 points, there are 10 intervals. Then we're going to loop over all the cells from here to here and record all the guess values in this block that I actually color-coded from red to blue. So we're going to record all of them and save them into a variable phi ji. Okay, now j corresponds to the row and I corresponds to the column. Okay, exactly the same as what's explained here. So j is along the row, or along the rows, and I is along the columns. Right, so we get different columns, we get different i's. You go along different rows, you get different j's. All right. So after we read all the vij's or vji's, then we're going to go over a loop 15 times, and we're going to update the phi in vji. Basically, we're going to update all the phis at the grid points 15 times, and after that we're gonna write back the phi ji onto the spreadsheet. So this is the writing part. We go over j and I and report the phi ji to the spreadsheet, the corresponding cell, the phi ji. The first cell we're going to write is actually right here in row 3 and column 2. That's why when j is 2 and I is 2, the first cell that is updated is actually cell row 4 and column 3. So row 4, column 3. So this is the first cell we're going to write. Then there is a reason, because in the textbook, in example 8.6, the boundaries all around this block are given. So we're not going to update them, right? So it's 1 here, 0 here, 0 here, 0 here. And the cells we update is the interior. That's why this is the first cell we're going to write. But in the homework, if you're updating the boundary due to like insulating boundary condition, you need to incorporate these, or you need to update these values on the spreadsheet. So the write commands will be different, just to let you know. Okay, so this is the write command. Let's go back to the loop over phi ji. For every ji, first we're gonna record the current values as old. We're gonna update it, and then using this update or calculate it, and the old value, we're gonna have the new value. And this exactly corresponds to equation 8.26 in the textbook. So if you go back, 8.27, where we have the SRF coefficient. So we get it calculated, we got the old value, the difference multiplied by SRF, plus old, you get the new. And this is it. So this is the calculated, this is old, the difference times SRF plus old gives you the new value. Oops. Okay. Now here, this equation is exactly equation 8.24 in the textbook. I'm sorry, that's 8.26. Yeah. So phi ij, actually no, it's 8.25. So these are the same. Here the book assumes the delta x, delta y are the same, but if they're not, then actually this is very general. This is specific to the case that delta x and delta y are the same. Alright, so we're going to implement this equation. Is del x squared times this plus del y squared times that divided by 2 del x squared to del y squared, and that's exactly what we have here. So you can easily do comparison and see that they're exactly matching ij minus 1, so here ij minus 1, and so what you have to note is the I and j are swapped in the code compared to the text, because in here, okay, so J is supposed to be along the rows, right? So exactly like in linear algebra, the first index in matrix is the number of rows. So J is going to be the number of rows, but in the text, because J is along the y-axis, and the textbook actually has this convention that x index comes first and y index comes next. It writes it as I and j, because I is the index for x and j is the index for y. But in matrix, or in linear algebra, the row index comes first. Unfortunately, the row index corresponds to y index. So that means this j minus 1, which is the second index, in the script becomes the first index. And I, which is the first index in the text, becomes the second index in the code. So we're going to swap the first and second index just because the y-axis, which is going to be the second index in math, is going to be the rows in Excel, which is going to be first index. So that's the difference. Hopefully it doesn't confuse you. Okay, so anyways, you're going to go over the phi ij using equation 8.25. You're going to update it after you update all of them 15 times. Then you're going to write it on the spreadsheet. So this is it. This is example 8.6. I'm going to show you the difference between this and homework 9, second problem. So here's homework 9 and second problem. So the difference is, first, these boundaries, right? So the left column and the bottom row, these are, well, like up to here. These are not given. You have to calculate through the insulating boundary conditions. So when you update, you have to also update this column and this row in addition to the interior points. So these are interior points. Top boundary and right one are given, so you don't need to update. Interior points need to be updated, as well as the left and bottom boundary. Given that, so here's the code. Let's look at the differences. So this part is the same, declaration is exactly the same. You read the values from the spreadsheet, that's also the same. The first difference comes here. In example 8.6, we went over this loop 15 times, but now we're gonna go over this as long as the error is bigger than 10 minus 5, or 10 to the minus 5. Okay, and also if the number of iterations is more than 1,000, we're going to break this loop. So we replace that 15-time iterations to this while loop with threshold, with maximum error threshold and maximum number of iteration constraints. Okay. So how we calculate maximum error? Every time you calculate phi ji, you subtract that one from the old value. You get the absolute value of it. You call it maximum error. You compare it with the maximum error old. If this one is bigger than maximum error old, then maximum error old will be this new value. Otherwise, the maximum error old is kept intact. All right. So this loop now cycle through the for loops as long as the error is bigger than 10 minus 5 and the number of iterations less than 1,000. This is useful because just in case if there's a bug in there and this condition is never satisfied, right? Then if you don't have this condition, this loop is going to run forever and you're going to crash your machine. So not to crash the laptop, you need to have this extra condition such that if there isn't a bug in there, you never go more than 1,000 cycles. Right, after you went over the grid points once, then you update the boundary conditions. This is the left boundary using forward Euler, right? It's forward because index in I is increasing. I is equal to 1, 2, and 3 here. So this is completely forward Euler. On the bottom, you use backward Euler. So the index for j is m here, then m minus 1, m minus looks like it's going back, right? So backward Euler for bottom, and then forward Euler for the left boundary conditions. After you do that, then that's the end of the while loop, right? So then you iterate over the while loop you go to the next cycle over the whole step. So this covers the grid points, the interior points. This covers the left boundary. This covers the bottom boundary. You go back up and reiterate. Okay, at the end of the loop, you're gonna print out the number of iterations. Yes, and then the maximum error you get. After that, you can write back all the phi ji's from 1 to m, all of them to the spreadsheet, not just the interior or just the boundary. You're going to include both of them. The interior and the boundary will be printed to the spreadsheet. Okay? So let me see, in the next few minutes, let me see if I can run this for you. So I'm going to start with initial guess here. So I'm going to set all of them to 1. Let's see, so here all are 1. Okay, so this is, I just put all of them as guess, except the top line and the right boundary. Okay, so I'm gonna go and save this. Go to the script here, and tools, and let's say run, reset, and run it. There you go. So the values are updated here, as well as the bottom boundary and the interior, except the top and right, because these are given, the code doesn't update them. It's just true. And then you get the cross section through the middle column and the middle row to get the two plots for variation of phi along the y-axis and phi along the x-axis. Okay, so this completes the description of the VBA script for example 8.6, as well as the second homework problem in problem set 9. Okay, so thanks all for watching. Stay tuned for the next video on optimization for chapter 9.